Hello, everybody. Mr. B here again. We're going to continue with our fraction series of videos, and this is video 8. And we're finally going to learn how to add and subtract fractions. All right. Adding and subtracting is easy if the denominators of the given fractions that you're adding or subtracting are the same. We call that a common denominator when they're the same. All right. Here's in the boxes the rules for adding and subtracting. It's basically the same rule. It's just one is a plus and one's a minus. So you can see that the fractions we're starting with both have the same denominator. I'm calling it B. These don't have numbers. It's just letters that represent numbers. All right. So what do? We add the numerators. Don't add the denominators. You just keep the same denominator you have. So the end result has the denominator that the fractions have, and then you add the numerators. Subtraction is almost identical, except you subtract the numerators. Okay, let's do one of these for fun. We've got 3/8 plus 1/8. So the denominators are the same. We just add the numerators, keep the existing denominator, 8, and 3 plus 1 is 4. We get 4/8. And like we did when we were doing multiplication, sometimes the end result needs to be reduced to simplest terms. So we need to reduce here. What is the common factor? Actually, you can see the greatest common factor is 4. 4 divides into 4, 4 divides into 8. 4 divides into 4 once, 4 divides into 8 twice, and the end answer is 1/2. Okay, well, what happens if the denominators are not the same? Well, this is pretty easy too. And the previous videos, there was a previous video that talked about the least common multiple. Maybe review that if you don't remember what that was all about. Essentially, we have to get equivalent fractions for the given fractions that have the same denominator. And the best common denominator to get is the least common multiple of the given denominators. And sometimes people call that the least common denominator instead of the least common multiple of the denominators. So what is the least common denominator? It's the smallest possible common denominator that you can get equivalent fractions for. Okay. Here is an example problem. You can see that we're adding these two fractions. They have different denominators. We need to get the least common multiple of these two denominators. And just to go through the process again, you might look at this and go, oh, it's 36, because we did this in the previous video, 12 and 18. But if you're starting from scratch, you're going to want to do a prime factorization of both of these denominators. So I'm doing factor trees for 12 and 18. I make that table with the stacks, and we ask the question, well, what's the most 2's we see in either list? We get 2 2's and we get the 2 3's. And so the LCM, which in this case is the least common denominator, is going to be 2 times 2 times 3 times 3, which we said was 36. Okay, so now we have to take the fraction 5/12, and I'm doing this the long way, if you might remember doing this in another video of getting equivalent fractions. We start with this. We want a denominator of 36. We're given 12. We start with getting this number. So what is the number that you have to multiply 12 by to get 36. Well, it's 3. It's 36 divided by 12. It's 3, and the top has to be 3 so that this thing equals 1. 5 times 3 is 15. Maybe this other one we'll do in our head. Remember how we could do that? We just write the other fraction that you want with the denominator you want. You go 18 goes into 36 twice, and we multiply the numerator by that too and get 14. So now we're done. Essentially, we've just been able to say that 5/12 plus 7/18 actually is equivalently 15/36 plus 14/36, which now we have common denominator. That's going to be our new denominator when we add. Maybe I'll write it out. 15 plus 14. That's what the numerator is. We get 29/36. And that's fully reduced. There's no common factor other than 1 between the numerator and denominator. All right. I know it looks like a lot of work. Sometimes, though, you just sort of look at these and you know what the denominator should be, what the LCD is, and you do this equivalency bit in your head. Maybe we'll do that in a later example. Okay, let's do another example. Let's do a few of these. All right, here's our next example. This one, we don't really need to do a factor tree. The given denominators are prime numbers already. So 5 is 5 and 3 is 3 for prime factorization. We just have to multiply 3 and 5. So the LCM, which is the LCD for our addition, is 3 times 5. That's 15. We could write this out, like this. 5 goes into 15 3 times. 3 times 2 is 6. What's the other one? 1/3. We want 15ths for the denominator. 3 goes into 15, 5. 5 times 1 is 5. So there they are. What I like to do, since this is pretty easy, is instead of write them here, I could just write them here. We know 15 is the LCD, and then get the numerator by working in our head here. So 5 goes into 15, 3. 3 times 2 is 6. 3 goes into 15, 5. 5 times 1 is 5. Now we're ready to add. The denominator is our LCD, 15. And then we have to add 6 and 5, which is 11, and we're done. 11/15. When the denominators of the given fractions are a single prime number, it's always going to be that you just multiply them. So for instance, here I'll do another quick example here. Let's say we're doing 1/2 plus 1/3. What do you think the LCD is here? Well, we can make a little table, but we don't need to. The single prime number in each, it's going to be 6, 2 times 3. So we would go like this. 2 goes into 6 3 times. 3 times 1 is 3. 3 goes into 6 twice. 2 times 1. And we quickly get the answer is 5/6. Okay, so this is yet another example. Okay, let's continue with another example. 2/3 minus a 6. So now we've got a subtraction. Some of you can probably already see that the common denominator should be 6, the least common denominator. But we could do a table. 3 is a 3, and 6 equals 2 times 3 if I make the usual table. How many 2's? 1. How many 3's? 1. So the LCD is 2 times 3 is 6. Let's do what we did in the other one, where we just do the work in our head like this. So we're going to have something over 6 minus something over 6. Well, we already know that one. It's given in 6, 1/6. But what's 2/3 in terms of sixths? 3 goes into 6 twice. 2 times 2 is 4. So now we have 4 minus 1. We can even do that in our head. 3 over 6. We need to reduce. Why? Because there's a common factor of 3. 3 goes into 3 once. 3 goes into 6 twice. And the answer is a half. Okay, let's do a little more complicated one with larger denominators. 40 and 15. It may not be immediately clear what the LCD is, so let's just do this the long way. Let's do factor trees for these denominators. Okay, so 40. How many 2's? We got to get 2's first. 2 goes into 40. 20, 2 still goes in. 10, 2 still goes in. 5. Okay, we have primes on all the branches. This one, 3 is the smallest prime that'll divide in 5 times, and we're done. Okay, so let's make our table. 40 is 2 times 2 times 2. And then there's a 5, but I know I got to squeeze a 3 in there for the other one. So 15 is a 3 and a 5. Remember the stacking rules that we were using. That's why I'm putting them all together like this. Okay, so we asked what's the most times you see a 2? Well, we get 3 of them. How about 3's? Well, we have 1. 5's, they're tied, so we just circle 1. And now we see that the LCD, I'm just going to call it the LCD instead of the LCM. The LCD, the least common denominator, is going to be all the numbers in the circles multiplied. That happens to be 120. 15 times 8 is 120. I don't know. Can we do it without doing it the long way? Let's do it the long way. Okay, so 3 over 40 times something over something is 120. 40 times what is 120? Well, 4 times 3 is 12, so it must be 3. 40 times 3 is 120. This needs to be a 3, so that this is 1. 3 times 3 is 9. Okay, so we get an equivalent fraction of 9 120ths for the first one. And why is my pen not working? There it goes. The other one is 3/15 times something over something to give 120. Well, we just said 15 times 8 was 120, so 8. This has to be an 8. 3 times 8 is 24. So now we have our 2 equivalent fractions to the given ones. The result will be the same common denominator, 120, and then we have to add 9 plus 24 is 33. Ooh, this needs to be reduced, though. I can see that the numerator is divisible by 3, and so is the denominator. So 3 goes into 33 11 times, and 3 goes into 120 40 times. So we get 11/40ths for our final answer, fully reduced. We needed to reduce this. Okay, got that. This video is getting a little long. Sorry about that. One more, that's subtraction. I've already built up the table so we can see that our LCD is going to be what? 2 times 2 times 3 times 3, that's 9 times 4, that's 36. Okay, this one I think we can do in our heads. 36. 9 goes into 36, 4. 4 times 7 is 28. 12 goes into 36 3 times. 3 times 5 is 15. And our answer is going to be 28 minus 15. What's that? 13? 13. And that's a prime number, and it does not divide into 36, so that's our final answer, 13/36. All right, I've got one more example, and this one's got some variables, has a variable in the denominator. So if you're doing algebra, you might see something like this. I've already made the table for these. So what's the most times we see a 2? 3. We've got 1, 3, and we need 3 x's. So the LCD is 2 times 2 times 2 times 3 times x to the third. I'll just write it that way. This is 8 times 3. That's 24x cubed. Let's do this the long way, like this, so we can see what we're doing. I'll write the other one out. 11 over 6x cubed times something over something has to give us 24x cubed. All right, back to this one. 8x times what gives 24x cubed? For x's, you can see we need 2 more x's. We got 1 here, we need to add 2 more to get 3. 8 times what? 3 gives 24. So this needs to be 3x squared, top and bottom. Why? So that it's 1. We're getting an equivalent fraction. All right, 5 times 3x squared is 15x squared. So there's our first one, our first equivalent fraction that has our LCD. And the next one, well, x cubed and x cubed. We don't need any more x's. We just need a number. 6 times what is 24? Well, that's 4. So we need a 4 on top. 11 times 4 is 44. 44. And we have 24x cubed in the denominator. And so that's our denominator in our answer, 24x cubed. And these are not what they call like terms. There's no x part on this. There's no variable part on the 44. So we can't combine this. We just leave it 15x squared plus 44. And that's our answer. All right, sorry about the long video. We'll see you in the next one.